All right, so now that we have gone over all the quadrilateral properties and you've applied them to problems, at this point you should be able to recognize a shape based on its properties, right? So first, let's decide, okay, what do we think this shape is? What do we think it is?
A rhombus.
Okay, so if we think it's a rhombus, why do we think it's a rhombus?
Because just look at it.
So what is special about a rhombus that would tell us this is a rhombus? Yes?
It has two parallel sides.
Okay, it has opposite parallel sides. What else? Yes, Tess?
Both sides of the grid.
Ah, okay. So in order to prove that this is a rhombus, we have to show two things. We have to show that all sides are congruent, and we also have to show opposite sides are parallel, right? There are other things that we could show here, but they don't necessarily tell us it's a rhombus, right? Okay, so the first thing that I would have done here was label my points with letters because that would help me keep track of the sides. Now, when I am labeling on a graph, well, actually any shape, when I'm labeling any shape, and it tells you, okay, the vertices are A, B, C, and D, you have to label in order. So you have to label in like a circular fashion. You can't go A, B, and then jump across the shape down there to C to D, okay? The reason you can't do that is because labeling in a circular fashion is just the accepted way to label. And it makes a difference, maybe not necessarily here, but say on a problem they didn't give you a picture, okay? Say they just said angle A is equal to 45, angle B is X, angle C is 3X, and angle D is 5X. If you don't label in order, then your angle B, it says on your paper, will be congruent to angle C, but that's not necessarily true, right? Because C is supposed to go up here, A, B, C, D. Does that make sense?
Yeah.
I know I just did a lot of word vomit just now, but just remember, when you're labeling any type of shape, go in a circular fashion, okay? A, B, C, D. All right, moving on. So we said we had to prove two things. What were those two things? We had to prove that the side lengths were congruent. Okay, so we have to do side lengths. Whoops. Side lengths. And we also had to show opposite sides parallel. Okay, so there's two things we have to show here. Now, how can I get the side lengths? Why is this not working? How can I get side lengths, guys? Pythagorean theorem. Yes, we can clearly just write on the graph see that AB is how long? 4, right? You can clearly see that AB is along the graph, so it's just 4 units long. How long is CD? Also 4. Again, you count along the graph, 4. 4 units. Now, like we were saying before here, to find the length of BC, it's going diagonally. So how do you find a diagonal length on a graph? Pythagorean theorem, yes. So we're going to create a right triangle. Like so. Where our A is how long? 2. And our B is how long? 4. And we're obviously trying to solve for this third length C. So BC is going to be 2 squared plus 4 squared equals C squared. Now what is the square root of 2 squared plus 4 squared? 4.47. Beautiful. And then we have to do the exact same thing for AD, create your right triangle. Oh, look, it's the same values, 2 and 4. So how long do you think AD is going to be? Again, it's 2 squared plus 4 squared equals c squared. Square root of 2 squared plus 4 squared is 4.47. So taking this information into account, are we changing what type of shape we think this is? Do we still think it's a rhombus? Why do we not think it's a rhombus anymore? Right, are all of the sides congruent? No. Opposite sides are what? Opposite sides are congruent, so what do we still think this is now? It's still a parallelogram so far, right? But we still need to prove what? Yes, and how do we do that? How do we prove the angles in a parallelogram? Our opposite angles are the same. What do you think we do? So, okay. Can we, at this point, which we're going to when we learn trig, at this point, can we find maybe the angle measure of B? Have I taught you any way to find the angle measure of B? No. Can I look at this and say, oh, B is 120 degrees because it looks like it? No. If we know blank about the sides, we can then know the angle measures. What is the blank thing that would tell us opposite angles are congruent? Oh, if the sides are parallel, would that tell us these opposite angles are congruent? Why, yes, it would, because if, say, AB is parallel to DC, A and D are what type of angle pair?
Supplementary.
Ah, because they're same side interior, right? And B and C are what type of angle pair? Supplementary, right? And therefore, if A is supplementary to D and B is supplementary to C, B has to be congruent to D, proving that yes, opposite angles are congruent and consecutive angles are supplementary. So it's just a roundabout way of proving the angles are congruent and supplementary. So we have to show opposite sides are parallel. How do we do that? Yes? Oh my gosh. Well, all we need is the slope. We don't really need the y-intercept. So how do I find the slope of AB? Rise over run. Well, what's the rise? 4. What's the run? Of AB, what's the run? No. A to B, what's the run? 0. 0. It doesn't run at all, right? It goes up 4. It doesn't go over at all. So what is 4 divided by 0? No. Undefined. Undefined. So this slope is undefined.
I really hope she uploads this to her website. So I can go over something.
And then let's find CD. Undefined. Undefined. And the rise on CD is 4. And the run is? So our slope is? Are these slopes the same? Yeah. Therefore, these lines are parallel. Good. So now, BC. How do we find the slope of BC? Rise over run. 2 over 4, which simplifies to? 1. And then AD. Again, 2 over 4, which is 1/2. Are the slopes the same? Which tells us that this shape is a what? Oh, it's a parallelogram.
So on the quiz you got to do.
No, on the test you are. So If, instead of these slopes being undefined, say they were -2, would that change what type of shape we think this is? Say both the undefines were -2. Let's think about it. What would that mean? No. It'd be a type of parallelogram. What is 1/2 in hold on. What is 1/2 in comparison to -2? I know you know this.
It's a square.
Negative reciprocal, which if you have negative reciprocal slopes, it means that the sides are perpendicular, so it would be a rectangle. All right.